let's go ahead and get started with these. So what we're going to be looking at again in 5.5 is we're going to be using what's called zero factor. And you'll be using this technique a lot in college algebra. This is a very, very important section. And what we do is, just as the name implies, we set our equation to 0, we factor it, and we solve. That's why it's called zero factor. So set to 0 and solve. And we're going to start with question number 2, which is 3x minus 9 times x plus 2 equals minus 25x minus 53. Now, sometimes, like on this question, you may have to FOIL it out before you set it to 0 and then refactor it. So this one's going to require us to FOIL. Remember how we FOIL? First and first, outside and outside, inside and inside, and finally last and last. So I'll do that over here. So we have 3x minus 9 times x plus 2. And again, we're going to be FOILing here. So let's go ahead and FOIL. First times first, that'll be a 3x squared. Then we have a 6x. Then we have a minus 9x and a minus 18. Combining like terms, we get 3x squared minus 3x minus then your 18. Okay, so that's going to be over here as 3x squared minus 3x minus 18. On the right-hand side, we have a minus 25x and a minus 53. So what do we need to do next? Well, zero factor is the property that we're going to be using. So we're going to go ahead and set this to 0, just like it says, zero factor, set to 0, and then factor. So I'm going to add that 25x over. And then I'm also going to add on that 53. So let's see what we get here. We move that over. We end up with a 3x squared. And then we've got 25 minus 3. That makes it a positive 22x. And then we've got 53 and a minus 18. That then leaves you with a 35. And that equals 0 there. And let's just take a moment to double check. You always want to make sure that everything looks right before you go on further. So we wrote it out. Okay, we FOILed. That's 3x squared. It's a positive 6x. That's a minus 9x. Minus 18. Combine those together. That gave you a minus 3x. Okay, and let's see. I don't know if you need this one or not, Raphael. Let's see. I don't know if you have this one or not. Take this out fast. I think you might have it, but try to. You're welcome right now. All right. So what we're now going to do is we have this set to 0. So we're going to try to factor it. Nothing comes out, right? Because we have a 3 and a 22, and those have nothing in common. So we are going to now go ahead and try to factor this. So what do we have? We have a trinomial. How do we handle the trinomial? We take the first times the last, and that gives me a 105. Now that 105 is positive, so what do I know? Well, if it's positive, that means the signs are either both positive or they're both negative. What's the sign in the middle? Positive. So these are both going to be positive. Now, what do we know about 105? Well, it ends in a 5. So we're going to start with multiples of 5 and keep going until we find it. And we can work with this. So we'll try 5. That's 5 and 21. If I add them together, they definitely do not give you 22. So let's try, a 10 won't go in there. Let's try 15. 15 and 7. Well, 15 plus 7, that's a 22. So those are our two numbers, 15 and a 7. Now, we cannot just jump to our factors because of the 3 in front. So what must we now do? We must break it up and factor it by grouping. So there is 3x squared plus 15x plus 7x plus 35. And we break this down just like we would before, and it's still equal to 0. So what are we going to do here? We're going to factor a 3x out, and that leaves you then with an x plus 5. Over here, we'll factor it a 7, and that's also going to leave you with an x plus 5. These are the same, which they should be. So x plus 5 comes out. 3x plus 7 is left over. All right with that so far. Now, what are our solutions going to be? Well, is it been set to 0? Yes, main thing is to make sure it's been set to 0, which it has been. It's been refactored. And so what do we have? We have x plus 5 equals 0. So x equals now a negative 5. All right. And then we've got 3x plus 7 equals 0. 3x equals negative 7. So x equals now a negative 7/3. So those are our two solutions. Okay, so that's what we do. We set it to 0. Now, before you do that, you may have to factor, or not factor, FOIL. So you may have to FOIL or use your distributive property to get rid of the parentheses, set it to 0, and then refactor it. All of these should factor. If they don't factor, you made a mistake. Question 6 is a little bit different, but still, same concept. We have 2p cubed minus 9p squared minus 50p is 225 equals 0 here. Okay, let's talk about how many solutions that we could have. What's our highest power in this case? Our highest power is cubed. Okay, so that tells me I can have up to 3 solutions. I may only have 2, or I may just have 1, but you can have up to 3. We have 4 terms, so I'm going to factor this by grouping. And we're going to see how we can group them together to make it work. So the first 2 pieces, all I can factor out is a p squared. And that's going to then leave you with a 2p minus 9. Now, over here, what are we going to factor out? Well, we have a 50. We need a 2. So 50 divided by 2 is a 25. It's negative, so we're going to factor it a minus 25. And 50 divided by 25, negative and negative, makes it that positive 2p there. 225 divided by 25, that should come out to be, we did it correctly. Yep, that comes out to be a 9, doesn't it? Right, 225 divided by negative 25, that makes it a negative 9. Is everyone all right with that so far? Okay. Now, what do we know from here? Are the groupings the same? Yes. So that comes out as a 2p minus 9, and what's left over? P squared minus 25. We are not done yet. Some of these may require you to factor and then factor again. Why are we not done? Because p squared minus 25, well, 25 is a perfect square of what? 5, right? So we can factor it again. You have to break it down as far as it can possibly go. So now we have 2p minus 9. This factors into p plus 5 and p minus 5. And now everything is factored as far as it can go. And we can now get, in this case, 3 answers. So 2p minus 9 equals 0. So 2p equals positive 9. So p equals then 9 halves. So there's that one. Then we've got p plus 5 equals 0. So move that over. P equals negative 5. P minus 5 equals 0. So moving that over, that gives you your positive 5. We have 3 solutions. And that's what we kind of would have expected because our highest power is 3. Most we could have had is 3. May have only had 2. But in this case, we got 3. Is everyone okay with that? So some of these you have to factor and then factor it again. You might have a difference of squares left over. Whatever you have left over, always make sure you can't go any further. So that's question 6. And these are just getting you ready to do the rest of them on your own. Question 12 is 4x plus 4 times x minus 4 equals now 3x plus 2 x minus 5. Okay, so how do we handle this one? Well, this is going to be done in a similar manner to what we did for question 2. We've got a FOIL. But in this case, we got to FOIL twice. We got to FOIL the left side, and we have to FOIL the right side. So let's see what we have. We have 4x plus 4 times x minus 4. So we're going to FOIL. Draw your arrows if you need to. And 4x times an x, that's a 4x squared. And then we've got outside and outside, that's a minus 16x, a positive 4x, and a negative 16. Binding those together here, we now get a 4x squared, and we have a minus 12x minus 16. So there's that half. We then repeat the process on the right-hand side. So we're going to have to FOIL again. And make sure I didn't make a mistake here. Let's just double check quickly. Everything looks right. Okay. Always double check yourself. It's very easy to make a mistake. So now we have 3x plus 2 times x minus 5. And again, we're going to FOIL. Draw the arrows if that helps, and write it out and see what we have. So if we FOIL, we get 3x squared. We have a minus 15x, a positive 2x, and a minus 10. Those can go together. And that leaves you then with a 3x squared minus 13x minus 10. So this is what we've got now. So what's our procedure going to now be? Well, we have it all FOILed out. We need to set it to 0 and then refactor once again. So move everything over to the left-hand side. So move your 3x squared over with subtraction. Add your 13x. Add your 10. Very, very careful when you put these together. It's very easy to make a sign error or add incorrectly. So 4 minus 3, that leaves you with an x squared. A minus 12x and a positive 13x, that leaves you with a positive x there. minus 16 plus 10, that leaves you with a minus 6. Now, this one is going to be very easy to factor. We do not have to use groupings because there's a 1 in front. And we just multiply. First times the last is a negative 6. And what do we know about the signs? Are they the same or are they going to be different? Well, that's a negative in the box there, right? So what do we know? How can you multiply together to get a negative number? A positive and a negative. What's the sign in the middle? This is positive. So our bigger number is positive, right? Smaller number is negative. Easy to factor. How about 3 and 2? You could check because 3 times a negative 2, that's a negative 6. And 3 minus 2, that's a 1. That's what we want. Because of the 1 in front here, we can jump directly to our factors of x plus 3, x minus 2. And what does that give us then? That gives us x plus 3 equals 0. So x equals a minus 3. X minus 2 equals 0. So x equals 2. Okay, so those are our 2 solutions for that equation. And why do we only have 2? Because what is our highest power? Okay, our highest power is squared. So it should be that. Make sure you've got that homework that says, I think I gave you the right one, Claudia, but you might double check. It should be 5, 5, 6, 1, and 2, right? Okay. So that takes care of the questions in out of 5, 5. I picked a couple of them out of 6, 1, and 2 to look at as well. So let's talk about question 7. These are usually not difficult to factor, but there's a lot of factoring that you have to do. So we have 3x squared minus 8xy minus 3y squared over y squared plus 3xy minus 4x squared. And we're going to be multiplying that by y squared plus 4xy minus 5x squared over 6x squared plus 5xy plus y squared. And then we're going to be dividing that by 5x squared minus 14xy minus 3y squared. And this is a lot of writing. They're actually pretty easy to factor. But we're going to have to factor every single one of these out. 2xy minus y squared. And are you ready to take that exam then? Okay. Right back just a second here. Okay, so we're going to factor each of these out individually, rewrite it. We'll do some cross-canceling. We'll work with this division here. But first thing we're going to do is we're going to factor each of these. So our first one is 3x squared minus 8xy minus 3y squared. This one's going to require us to factor by grouping. First times the last, minus 9. We need minus 8 in the middle. So how about we use minus 9 and 1? Okay, pretty easy to factor there, right? Okay, now we got to break it up by grouping. So that's 3x squared minus 9xy plus xy minus 3y squared. Factor and factor. So 3x comes out. That leaves you with an x minus 3y. Next one, y comes out. That leaves you with an x minus 3y. Those again are the same. So that gives you x minus 3y, 3x plus y, right? Okay. I know these take a bit. These are not something that you can just do real quickly unless you're really good at factoring. So that's that piece. Now, let's do the other one. Let's do the one that's down below. So we'll work with this denominator, y squared plus 3xy minus 4x squared. Okay, first times the last. That's a minus 4. It's negative. We want the middle to be positive, so how about 4 and minus 1? This one is nice. Because of the 1 in front, we don't have to group it together. That's going to be y and y. And we've got positive 4x, right, and a minus x there. Okay, so it looks right so far. Just make sure you take your time with these. Just so we don't lose track of anything, I'm going to highlight these real quick here. So we've got them. These, again, are not my answers, but they're only part of it. We factor the next set. So let's see what we've got here. Well, this one is y squared plus 4xy minus 5x squared. So that one, we should be able to jump directly to our factors again. First times the last is a minus 5. We need a 4. So how about we use 5 and minus 1? Jumping to our factors, we have y and y, x and x here, and then we have a 5 and a minus 1. Okay, next one, factor by grouping for this one. And I know these are tedious, they take time to go through. But there's no quick way around it. Y plus y squared. Okay, so first times the last is a 6. And both the same signs. We need a positive, so how about 3 and 2? So that is then, since we have a 6 in front, 6x squared plus 3xy plus 2xy plus y squared. Factor out 3x. And that leaves you with a 2x, looks like, plus y. Factor out the y here. This is all things we've done before. It's nothing really new. And that leaves you then with the same 2x, right? Plus y. Those are the same. Now we have 2x plus y, 3x plus y. Got 2 more to work through. Then we can put it all back together and reduce it all down. And this is probably going to reduce down quite a bit. We still have 2 more to look at because we've got our division here. So we have to factor those out as well. So that's what we're going to do next, is factor those out. And then we'll put everything back together once we're done. So we're going to start by factoring out that 5x squared minus 14xy minus 3y squared. So first times the last. Negative 15. Here's how I can factor them so quickly. What do you know about 15 and 14? 15 and 14 are really close to each other, right? That's a difference of what? 1. So we know 1 has to be a factor. Sign in the middle is negative. This is negative here. So what are we going to use? Minus 15, positive 1. Unfortunately, because of the 5, we have to factor by grouping. So that's 5x squared minus 15xy plus y squared minus 3y squared. Or sorry, not, let me write it right here. Sorry about that. That's going to be xy, not y squared there. My mistake. Now we can factor. First two, these have a 5 and an x in common, and that leaves you with an x minus 3y. We've seen that factor numerous times already. This one, what are we going to do here? Well, remember this is a plus. Sorry about the mess here, but this should be a plus xy here. We can factor out a y, and that leaves you now with an x minus 3y. These are the same. So what do we have? We have 5x plus y and x minus 3y. One more, then we'll put the pieces back together, and we will be done. So we have an 8x squared plus 2xy minus y squared. So first times the last, 8 times a negative 1, that makes it a negative 8. What two numbers can we use? Well, we know they're negatives, they have to be different. Multiply together to give you 8. Subtract from each other to give you 2. Can anyone tell me what the numbers will be? Let's make sure we know how this works. Multiply together to give you 8. Subtract from each other to give you 2. What two numbers would do that? Okay, let's make sure we can answer this pretty quickly here. Multiply together to give you 8. Subtract together to give you 2. What two numbers would do that? 4 and 2. Yep, so I want to make sure we're following along here. Now, why is it going to be a positive 4? Because it's positive here. So we need a positive 4 and a negative 2. Just trying to make sure we're all on track here. Break this down a bit. So 8x squared plus 4xy minus 2xy minus y squared. First two pieces, what can I factor out of here? Someone tell me what I would factor out of here. What do these have in common? Bigger than a 2, they both have a 4 in common, don't they? And what variable as well? These have the variable x, don't they? Okay, make sure we're following along here. I'm going to now take out a 4x, and that leaves you with a 2x plus y. Now, what about the next two pieces? What do we need to factor out of here? Well, let's look and see what we've got. These are both negative. We need them to be positive. So what can I factor out of here? To change our signs, I'm going to factor out a minus. And what variable do they have in common? They have a y in common. So I'm going to factor in a minus y. And that leaves me then with a 2x plus y. These are the same. So now we've got 2x plus y, 4x minus y. This was question number 7 from 6-1 and 2. We're mostly done. We have done all the hard work. So now we're going to rewrite it, and then we'll start canceling and working with it. So everything has been factored. So let's write out what we've got when we factored. When we factored, we got x minus 3y, 3x plus y, and then we've got down below on that one, we've got a y plus 5x, and we've got a y minus x. Next piece, we factored all of it down, And we got a y plus 4x, y minus x on the top in that numerator. Oh, wait a minute. Did I write things in the wrong order? Yeah. Yep. Sorry about that. I started to write things in the wrong order. Let's make sure we put it in the right order. Okay. So I factored across. So first one, okay. Make sure we know what we're doing. It's easy to make a mistake and copy the wrong one. This is there. That is there. Okay, so let's write it out. So what do we have? We have x minus 3y. We've got 3x plus y. That's that first numerator, right? Okay, because that is this piece right here. We factored it, we got to there. What about the next one? Down below, we have this. Okay, this factored into that. So down below it, we have a y plus 4x and a y minus x. So that takes care of that. Okay. Next, y squared plus 4xy minus 5x squared, that is that. Okay, so that's going here. These just take a while to rewrite. We've got that 6x squared plus that 5xy plus that y squared. We factored that down into 2x plus y, 3x plus y. And then we've got a division symbol here. And we factored the last one, right? The last one factored into this up here. Right? Factored into this up here. So we'll rewrite that. So 5x plus y, x minus 3y over 2x plus y, 4x minus y. Now, everything has been factored. We can now begin canceling. Do not cancel with this over here because this is division. I would probably say rewrite it again with multiplication and then just start canceling. So we're now going to just rewrite this one more time quickly with that multiplication instead of the division. All that does is that flips it over. So that's going to be it. And then we'll be able to cross cancel. See what we are left with. Some of the questions in this section take a bit to go through. Most of them are not this involved. I think there's only 2 of them that are this complicated. And when you take that division and you turn it into multiplication, what do? You flip the fraction over. So flipping it over, that's going to be a 2x plus y, 4x minus y on the numerator. Now, in my denominator, I have a 5x plus y down below and an x minus 3y. Now, we are set up to cancel. You can cancel however you can. Vertically, like across from each other, on the diagonals, however you can cancel is what you want to do. So let's just start, and we'll just cancel. So how about this x minus 3y? That can go with that. Then we have a 3x plus y. That can go with that, right? So those are okay there. And then we have a y plus 5x. Well, that's the same as that, just in a different order. So that can go. And we have a y minus x and a y minus x here and here. That can go. And we've got, let's see, a 2x plus y. That can go, and that can go. And so what is left over? What did not have a pair to match with it? Well, we have a 4x minus y in the numerator because nothing cancels with that. And what about the other one? Okay, the other one down to my denominator is a y plus 4x. Why can those not cancel? Well, to cancel and reduce down, they have to factor. The numerator won't factor. The denominator won't factor. If they don't factor, you cannot reduce. So that is your final answer. I know it took a bit to go through, but this is your answer for question 7. Some of these questions are quick to go through. Some of them take more time. 8's a little bit easier than 7, and 9 is a little bit easier as well, as long as you're careful with the factoring. 7 was the most complicated one, the time-consuming one, so that's why I did that one for you. I'll leave several of them for you to do, though. Okay, we'll do one more, and then we'll try to finish up this section. So let's now look at question 10. 10 is quite a bit easier. Okay, so for question 10, we've got f of x equals x squared minus 64 over x squared plus 3x minus 28. And you need to follow the directions. So this one says, find the domain. So that's my directions here. Find the domain. So this is much, much easier to work through. Okay? So this one's going to be a lot easier to actually work through. When we find our domain, I do not care at all about the numerator. The top half is irrelevant. I only look at the denominator, which is down here. So you're going to set that denominator to 0. It should factor out nicely. So we have x squared plus 3x minus 28 equals 0. When we talk about finding the domain, you do not have to worry at all about the numerator, the top half of that fraction. It doesn't matter. All right, that's irrelevant. When we talk about the domain, all we want is division by 0. So now we're going to be factoring this down. So what are we going to now do? Well, this should factor out easily. First times the last is a minus 28. Okay, 28, I can see it. How about 7 and negative 4? Why would that work? Well, 7 times negative 4 is negative 28. And 7 minus 4 is positive 3. We're in luck because we do not have to factor by grouping. So we can jump directly to our answers of x plus 7, x minus 4. Here's where students make a mistake sometimes. Our answers are not 7 and minus 4. You have to switch your signs by solving. So x plus 7 equals 0. Moving it over, we get the negative 7. X minus 4 equals 0. Moving it over, we get the 4. Now, how do we specifically write our answer? Well, these are the numbers that do not work. So minus 7 and positive 4 do not work because they give you division by 0. How do we write up our domain? Well, we write up our domain by starting from the smallest number. So we have negative infinity, and that's going to go to the smaller number, which is 7. You're going to use nothing but parentheses here. Then we're going to union that with that minus 7 and positive 4. We're going to then union that with 4 to positive infinity. That's how you find the domain of what's called a rational function. College algebra, you'll do a lot of these. This is something you would do in college algebra. It's just in college algebra, we move through things faster, and sometimes the questions are a little bit more complicated. But if you can do the questions from intermediate, you'll do fine for college algebra. As long as you know simple things like this, then you'll be fine in college algebra. Now, what I didn't cover last time was adding and subtracting of these rational functions, these fractions. So that's what we're going to look at today. So we're still in 6.1 and 2, and we're going to be looking at questions like 12 through 15. So 6.1 and 6.2. I'm not going to work these out for you, but we're going to pick questions like 12 through that 15. Now, what do we know about adding fractions? Let's take a moment to add these two fractions together. I'm going to give you two simple fractions, and we're going to add these together. So let's take a moment to think about how we add fractions. Now, when we add fractions, what do we have to have? Common denominator, right? Okay. Same process is going to take place when we have variables. But I wanted to do one with just numbers first, so we would refresh ourselves on how this works. We need a least common denominator. Okay? And we want to add these together. So the least common denominator of 8 and 4 would be an 8, right? So that means this 1/4, well, it has to be multiplied by 2 over 2. For how we would do these. So now we have 5/8 plus 1 times 2 is 2. 2/8, add those together, and what do we get? 7/8. Remember how you would add those fractions. So whenever you add or subtract fractions, you have to get a common denominator. We're going to start off with some simpler ones, and then we'll progress into some more complicated ones. Okay, so we want to simplify this down. So we're going to try to simplify this down. Now we have numbers and we have variables. So I always like to just start with the easier part first, so we'll do the numbers. Numbers are usually easier than the variables in a lot of cases. Least common denominator of 5 and 7. Well, these have nothing in common, so that's a 35. So the first one needs a 7 over 7, and the second one needs a 5 over 5. Now, how do we handle the powers? Well, when we look at these powers of the x, we see we have an x what? Squared. That's our largest power. So this one is a 5x squared. This one just has an x. So we need to make sure that this one's an x squared. So we're going to multiply it by an x over x. When I do that, let's now see what we get. We get 7 times 3. 7 times 3 is a 21. 7 times 5 is a 35, x squared. 2 times a 5x, that's a 10x. And down below, 7 times 5, that's a 35. X times x makes that an x squared. These have the same denominator, which they should. They can go together now as 21 plus 10x over 35x squared. And you could leave it like that, or you can simply rewrite it with the x first. It does not matter. you get the same answer. Those are exactly the same, so it doesn't matter. I would probably write it like this, but the other one's just as fine. It doesn't really matter. Order's not important. Normally, though, we write the X first. How do I know when to stop? Here's where students struggle with knowing when to stop. Can I factor a 10x plus 21? Do they have anything in common? No. Down below, nothing factors out. If nothing factors out, nothing reduces, and you are done. Let's do another one. So this one we're going to simplify as well. So we're going to look at this one. Now again, directions are simplified. So what we're going to look at here is we're going to look at our denominators. And least common denominator, let's start with the numbers. What numbers are out front? 7 and 3. These have nothing in common. 7 times 3 is a 21. So number-wise, I'm going to make sure I get a 21. So we'll rewrite again. And leave yourself plenty of room when you rewrite these. We know we need a 21. So this one has a 3. 3 times what makes it 21? 7. So we need a 7 over 7. And this one has a 7. We need a 21. So it needs a 3 over 3. Now, what else do we have? Well, notice these have an x minus 7y in common. This one's squared, this one's cubed. What's my highest power? Cubed. So I need to make sure that this one here is cubed. How can I do that? Well, I can multiply it by x minus 7y times x minus 7y. Now, putting the pieces back together, let's see what we've got. We're just going to put it under the one numerator here. And we can do that just to save rewriting and rewriting multiple times. Let's look at our numerator. 7 times 3, that's a 21. Or sorry, denominator. Look at the numerator, denominator. 7 times 3 in my denominator is 21. How many of these x minus 7y's do we have? 3 of them, right? 2 and 1 makes 3. This one's already 3. So that's a x minus 7y, and that's going to be quantity cubed. What do we have left over on the top? Well, 4 times 7. We just multiply here. 4 times 7, that's a 28. We've got x minus 7y. On the next piece, we have 2 times 3, which makes it a 6. You could leave it like this. I'm going to go ahead and distribute that 28 through. And that's going to then leave you with a 28x minus, we've got 28 times 7. So minus 196. And that's going to be y plus 6 over 21 times x minus 7y cubed. Okay, we might be able to go one little step further. What can I do? Well, look at these numbers. 28, 196, positive 6. What do they have in common? These all have the number what? 2 in common. So that's our last step. We can take that 2 out, and that's going to then leave you with a 14x minus 98y plus 3. And that's going to be over 21 times x minus 7 y cubed. How do I know I can stop? Can I factor any more out of this? No. Can anything be factored out here? No. Can anything cancel? Nope, because 2 and 21 have nothing in common. So this is the furthest that I can go. We broke it down as much as we possibly can. I'm going to pick a few more questions from our textbook to look at. Probably 2, maybe 3 if we have time. That will finish up 6.1 and 2. 6.1 and 2 is not difficult, it just takes a lot of time. These are not questions that you can do in 30 seconds. They take time, they take a lot of writing. So I'm going to find a couple of these for us to look at here. How about we look at question 80. And this is on page 403. And question 80. So we have 5x over x plus 3 plus x plus 2 over x minus 6 over x squared plus 3x. Let's all try to pay attention on this one, because this is one that is pretty simple, not that difficult. This is something that you might see on your final or something close to it. So first thing I want to do, see what I can factor in these denominators. X plus 3, that's fine, nothing factors. X, nothing factors. What about that? X squared plus 3x. Yes, what can come out of it? What can come out of here is an x. So let's rewrite this as x plus 3, that comes out. And now we can kind of see what we're working with. Each of these, well, the first 2 at least, are going to have to be multiplied by something. So let's see what we've got. What's our biggest fraction in the denominator? Well, it's an x times x plus 3, right? So this one here, our first one, well, it already has, you always want to look at your largest one. It already has an x plus 3. But what is it missing? It's missing an x. So I'm going to put the x here and here. X over x. What about the next one? What is it missing? Well, it has the x, but it's missing the x plus 3 or the x plus 3, right? Now, let's combine and see what we have. So we've got 5x times x. That's at 5x squared there. This, by the way, is all going to be over x times x plus 3. Then we have x plus 2 times x plus 3. It's there. And then we have a minus 6. Nothing need to be multiplied here because it's still over what? X times x plus 3. Now, we might be able to reduce this down a bit. We want to break up all of our parentheses so we can work with it. And we may have to FOIL. Some of these require all the techniques that we learned in Chapter 5, as well as some from 4. So let's take this, x plus 2, x plus 3, and let's FOIL it out. So that is x squared plus 2x plus 3x plus 6, which is then x squared plus 5x plus 6. So that's what we've got. Now, we should be able to combine multiple pieces together. Then we'll see what we're left with. And then we may have to factor it again. So let's see what's going to happen when I add these together. Because these can be directly added together. Why can they be directly added together? Because right now, they have the same denominator. So let's put these together. Let's see what we have. We have 5x squared and another x squared. That makes it 6x squared there. Because those can go together. And then we've got a 5x. And 6 and negative 6, well, those are gone. Now, we are not completely done yet because you always have to make sure that you can't factor. And I think in the numerator, if we look here, these both have the variable x in common. And that leaves you then with a 6x plus 5 over x times x plus 3. What do we know? The x's can cancel out. And so what's left over then when we're all done? Well, we are then left with a 6x plus 5 over x plus 3. And that is going to be our final finished answer. Okay, let's do another one. Question 88. So question 88 is 2 over m squared minus 4m plus 4 plus 3 over m squared. Are you finished, Cody? Sure. Huh? Which one? Yes, find the product of FOIL. Okay. Yep, FOIL them all out. Okay, so on question 88 here, we've got m squared plus m minus 6. And we're going to quickly factor these because these, you should not have to do grouping, and you should be able to factor them out really, really quickly. What about this one? 4 is a perfect square of what? 2, right? This is a perfect square trinomial, negative in the middle, so that's going to come down as an x minus 2 quantity squared, right? Because this is a perfect square trinomial, because that 4 is a perfect square. When you double it, you get the negative 4. What about this one? Well, first times the last is a negative 6. And what two numbers give you the 1? How about we need a positive 3, that's the larger one, and a negative 2. So that's what we've got there. Now, it's all been factored. We need to look at everything together. We're going to compare these fractions. So here's how we do it. We look and see what we're missing. So this one right here has an m minus 2. Or sorry, these should be m's, not x. It's my mistake. I wrote it wrong. Sorry about that. These should be m's here. Same thing. I just wrote the wrong variable. So those should be m's. Now, what do we notice here? Okay, this one has an m minus 2. That's okay. But what does this one not have that this one does have? This one has an m plus 3. This one does not. So the first one is going to need an m plus 3 over plus 3. What about the second fraction? What does it need? It has the m plus 3, which is okay there. This one is an m minus 2, but it is quantity squared. This one's only one of them, so we need another m minus 2 over m minus 2. Now, put it all back together, finish it out. So what do we have? We have 2 times m plus 3 over, what's going to be down below? M plus 3 times m minus 2, quantity squared. That's your common denominator. What about the other one? Well, the other one is a 3 times m minus 2. And we'll clean this up by distributing through. So let's distribute that 2 through. And now we have 2m, and 2 times 3 makes it a 6. And then we have a 3m, a minus 6, over that again, plus 3, minus 2, quantity squared. Clean it up. And I think this will be the last one that we're going to look at. So I'll go ahead now and pass out the sign-in sheet. I really don't think we have enough time to go through another one of these because they take about 10 to 15 minutes, and we don't really have that much longer left. So I'm just going to finish this one out. I'll go ahead and pass out the sign-in sheet. Now, what can we do here? Well, we need to combine like terms. So these are on the same denominator. So the 6 and the negative 6, those can cancel. What's left over then? Let's rewrite it. Well, what's going to be left over is 2m, right? That's there, plus 3m over m plus 3, m minus 2, quantity squared. Those are both m's though, aren't they? So 2m and 3m, well, those can go together, finishing it out as 5m on the top. And what's down below? M plus 3, bless you, m minus 2, quantity squared. And that is as far as we can possibly go. So what's your homework going to be? Well, your homework is going to be 6-1 and 6-2, and you can do them all. So that's going to be your homework.